Hi and welcome back. Today I'm going to be building a small Viking style hatchet. I'm looking for a tool that I can use one-handed to rough out basic carvings or other woodworking projects, but has a lot more cutting power than a simple carving knife. So I decided on this design because it's basically tailor-made for what I want to use it for. It has a wide, thin cutting edge, and the head of the axe is pared down to a bare minimum. So I'm hoping that this hatchet will give me pretty much the same cutting power as a regular hatchet, but with half the weight. So that's really going to reduce the amount of impact that the work is taking. I'm going to be building the axe by welding two separate pieces of steel together. The cutting edge is going to be a small piece of leaf spring, and the main body of the axe is going to be a piece of 3/8 by 1 flat bar. I'm going to start by placing an offset 2 inches away from the end of the bar. This is going to define one edge of the eye. I'm going to be using the traditional axe making technique where you wrap a piece of steel around a mandrel to forge the eye. I've measured the circumference of the drift that I'm going to be using for the eye, and I'm going to need between 3 3/4 inches and 4 inches in total length. So what I'm doing here is I'm creating the offsets about 3.5 inches apart, and I'm estimating that this should give me the right length once I get the eye down to the final thickness. I'm not getting too fancy with the scarf. I'm basically just thinning down the edge a little bit so there isn't too much mass at the tip. For this axe, I'm going to be approaching the weld a little bit differently. I'm going to weld a bit to one side of the head first, and then I'm going to wrap the eye and then flip it over and weld the other side of the head to the bit, instead of wrapping the eye first and welding the eye and then inserting the bit and trying to weld the two sides at once. The reason I'm trying this is because when you're welding small pieces of steel like this that don't have a lot of heat retention, it's really hard to get the anvil side of the weld to take because it's cooling so quickly. So I'm hoping that with this method I'll be able to get a better weld because the hot side is always going to be facing up. The other advantage is I get to use the full length of the bar while I'm doing the drop tong weld, which makes things a lot easier. At this point I'm ready to cut the axe from the bar, so I'll be making that cut 2 inches away from the other side of the eye. At this point I have a good weld between the bit of the axe and the section of the axe that's going to make the axe head. So what I'm doing now is I'm just working that weld back to the edges of the eye. The important thing to remember here is to take your time. Forge welding is a slow process and you just have to accept that. If you're working on projects where the weld isn't going to be under a lot of stress, you can shortcut the process and leave a forge weld that's maybe only 20% as strong as it could be. But when you're making tools, you usually need the forge weld to be as strong as it can be. So that means taking a lot of heats, doing a lot of careful hammering, and that means the process is going to take a lot longer. So at this point I'm ready to drift the eye. I'm starting with a narrow drift that'll just start shaping the eye, and it'll also tell me if I have any problems with the eye. If it starts to split and if I'm not happy with the way it's shaping, I still have a slim chance to be able to recover the weld and continue drifting. If it drifts well, then I'll just continue the whole process. Here I'm quite a bit further along. I've done all the grinding and finishing that I'm going to do to this piece, and I've been slowly heating it up until the steel is no longer magnetic. I'm not going to be quenching it right now. I'm just taking note of the color that the steel is at this point. I'm going to put it back in the fire, and then I'm going to bring it back to quench it. It's important to remember that you need to heat the steel up to this point and not beyond it. You can heat the steel until it's white hot, and it won't be magnetic at that temperature either, but that is way too hot to be quenching your steel. So you need to test the steel several times as you're bringing up the temperature, and as soon as it becomes non-magnetic, that's the color you're looking for. So you bring the heat up to that point, a little bit above, just to make sure that you've reached that temperature, but don't go too far above that because you will be weakening the structure of your steel. At this stage, the cutting edge is going to be way too hard to use, so we need to reheat the edge at a lower temperature to soften it somewhat and make it tougher and to remove some of that brittleness. This is usually referred to as drawing the temper. And the amount of temper that needs to be drawn from the steel is usually given a color range. And that's because all of these temperatures show up as a very specific color on a polished piece of steel. So sample 1 here on the left is a piece of steel with all of the scale ground off. Number 2 is usually referred to as a light straw color because this is what happens to the steel when it's heated to around 400 degrees Fahrenheit. Sample number 3 is the color of the steel when it reaches 425 degrees Fahrenheit. And so on up the scale, and each color range has a specific application. Some of the upper ranges are not going to be attainable in a regular kitchen oven, but for most woodworking tools you're looking at the colors that you see in sample 2 to 4. And of course all of these temperatures can vary quite a bit from one oven to another, so it's important to put a piece of steel in your oven and test it. Take note of all of the temperatures that produce the color ranges that you can get in your oven, and from that point on, that's the temperature you use. Even if somebody like me is telling you that I'm putting it in my oven for 400, if it's 380 in your oven, then that's what you use. Once the blade is done, you need to start shaping the handle to fit the eye. The first step is to trace the outline of the eye onto your handle material. Next, you need to start removing some material until the outside of the handle roughly conforms to the outline that you have drawn on the end of the handle. Once you can get the eye to fit over the very end of the handle, you need to drive the axe down onto the handle as far as it can go. Next, you need to remove the axe from the handle and then look at the handle to see where it's rubbing up against the eye and carve those areas down. And then repeating this process over and over again until you can drive the entire eye of the axe onto the handle. Now that you have a good solid fit between the axe head and the handle, you can go ahead and take the time to finish shaping the rest of the handle the way you like. Now that I have all the shaping done on the handle, I'm ready to make the relief cuts that are going to allow you to drive wedges into the handle. I usually use 3 saw cuts in my handles. One, of course, is right down the center of the handle, and I put 2 others across the narrow side of the handle, and I use those to push the handle into the front and the back of the eye so that I have a complete contact right around the whole circumference. Getting all the wedges in can get a little messy, but don't worry about that. The important thing is to have a really good solid connection between the axe handle and the axe. All of this mess is going to get cut away later. And here again is another look at the finished axe, ready to do some carving. Thanks for watching, and we'll see you next time. Hi, I'm Dennis, and thanks for watching. If you have any questions, you can contact me by using the email address that I have shown here. If you like the channel and the work that I'm doing, please consider becoming a patron. Every dollar you contribute will bring me one step closer to being able to produce videos full-time.